Hello again, let's get started. Guys, in this video, I did a copy and paste. Allow me to write the square root for what it is. It's the second root of x. That's what the square root has always been. And this would be a good chance to show that off. In general, your professor would probably want you just to stick with the old-fashioned square root right here. But this right here is really what the square root is. And I'm going to write it like that in this problem just to show it off for no other reason than just to show it off. Okay, now I'm going to do d by dx of the square root of x plus the square root of x. That's d by dx of, I use brackets here. You could just as well use a big old thing of parentheses, just whatever. Oops, sorry about that. So you could use big parentheses instead of brackets, but anyway. So the square, this inside guy is x plus the square root of x. So really, you read the inside first. We're doing x plus the square root of x, and we're raising that whole thing to the half power, which is this guy right here. We're raising that's a square root. The half power is a square root. We're raising that whole thing to the half power. So we're raising gobbledygook to the half power. And we're doing d by dx of that. Yikes. Sorry, I forgot my dx. We're derivating that. Yikes. So we not only have that, the whole reason I need these brackets is I'm operating on it. I'm doing the derivative. The derivative is an operator. So I'm operating on this. So remember a chain rule, we need to let u equal x plus the square root of x. And did I neglect to put that? Yep, I did. So we're going to let u equal x plus x to the half. And let me just note that here. So where u equals x plus, you could call it square root of x. I'm going to call it x to the half. So we're going to let this guy in parentheses here, this x plus x to the half, be u. So that here's u. So what we're going to do is chain rule. We do d by du of u to the half times d by dx of the u term in terms of x. So we do, or the u term is in terms of x. So we do d by du of u to the half times, now remember the sum of the derivative of the sum is the sum of the derivatives. I just go ahead and do that. Some problems I skipped this step, but I did it in this problem. Now let's execute the derivatives already. So d by du of u to the half, that's power rule, 1/2 u to the negative half. We subtract 1 from this half here. And then we go in and do this. D by dx of x is just 1. And d by dx of x to the half, we do the power rule. The 1/2 jumps down, and we get negative half up here in a similar fashion. Now, guys, what I do is I show off some algebra. Notice that the negative half, indeed, that is 1/2 minus 1. And then I write it here, and I write it here. I turn these neg halves into positive half minus 1 here and here. You're like, well, Jason, why'd you do that? Because by the law of exponents, what I've really got here is 1/2 times u to the half times u to the negative 1. But what that amounts to is u to the half over u. That u to the negative 1 comes down here as u. And that 1/2 is the same thing as dividing by the 2 down here, okay? Division by 2 is the same thing as multiplication by half. So we got that. So I skipped the step, but it wasn't a big step. The next step I would have done by the law of exponents, I'd had 1/2 times u to the half times u to the negative 1. But I'd rather write it like this. U to the half times, 1/2 times u to the 1/2 times u to the negative 1. Like that. And then this guy right here, the 1 plus just stays put. And now remember again, 1/2 times x to the 1/2 times x to the negative 1. That's x to the half over 2x. 1/2 can be thought of as division by 2. The x to the negative 1 goes down there with that 2 and becomes x to the positive 1. Now the x to the half stays upstairs. It was positive in power from the beginning. X is understood to be positive here. That was probably true on the last example as well. I didn't really mention it, but we always assume domain appropriateness. But anyway, now guys, we got to replace u with what it is. It's this is just the square root of u, but that's just the square root of x plus radical x. U is x plus radical x. And then we got now 2u down here. Again, u is x plus radical x, but now we got to put a parenthesis around it because we're distributing 2 through it. 2 is being multiplied by the whole thing. And then times, distributively, 1 plus, now we still got this x to the half over 2x. Well, if you want to, you can go ahead and, yeah, you could make this square root of x already. But anyway, what I do, guys, I go ahead and now notice that 1 plus square root of x over 2x. Let me just go ahead and make this a square root of x. There's no point in that delay, really. And again, the square root of x is synonymous with the second root of x. These are synonymous. So, but anyway, to get common denominator, you see this 1 here? I want to turn it into 2x over 2x, okay? That'll give me common denominator, and I can just bring these numerators additively together, and I'll have 2x plus radical x here, okay? And then, now you're like, well, Jason, how do you handle that x plus x to the half down here? Is it going to be as monstrous as the last problem? Thankfully, no. Remember, this is just x plus the square root of x, but by conjugation, we multiply that by x minus the square root of x. Now, but the only thing is you got to stick that term up here as well, up there as well. You got to multiply the top guy, and I ditched the 2's because they're understood. So we multiply that top guy, which is radical x plus radical x times x minus radical x. That's going to be, that's in general messy. But anyway, so we got all this, and then that's equal to, well, let's see. Now down here, by associativity, I'll go ahead and I multiply these two guys right here and here. This guy and this guy by associativity. But wait, there's something else I can do. I can bring this x over here to the very left, or almost to the very left. Or actually, I can bring it to the very left. I can do what I want by commutativity just about. I have to be careful if I distribute it, but I can do that too if I want to. But anyway, I'm going to see this 2 times 2x, that's 4x. So bam, there's that. And then remember, this is a plus b, a minus b, so it's going to be a squared minus b squared. Now, x squared is just x squared. Now, if you square radical x squared is just x himself right here. So there's that. That was our objective, to get the radical off that denominator. That's what we were in it for. And that's it. You could go ahead and you could do some distributing up here, but it would get quite unwieldy, and I just don't want to do it. This should be fine. I think many a professor would accept this format right here. If you went ahead, if you did some distributing, well, this third term would be a disaster. You kind of have to leave it alone. Well, there's stuff it would be undesirable. You would have to, leave the, you could bring some stuff in, but it would be fruitless and undesirable to do so. It would not necessarily incorrect to do so, but undesirable. You could go ahead, you could multiply this term and fall it over this term, but that doesn't seem fruitful to me. If we wanted to do it and just follow the bread trail, we would get, well, what would we get? We're not going to mess with anything but those. We're going to leave the denominator alone. Now, if we multiply by associativity, I can go ahead and multiply this guy and this guy. By FOIL, x times 2x is 2x squared. And we'll need to put parentheses around all this stuff because we're going to multiply it by this radical right over here in a minute. But anyway, by FOIL, F is these two terms. And then my outer is this x and this radical x. So that's just plus x radical x. And my inner term is going to be this 2x. That's going to be negative radical x times 2x. That's just negative 2x radical x. And then my last. Now, negative times a positive is a negative. Now, radical x times radical x is just x himself. Okay, so there's that. And then I have to copy and paste this guy right here. Oops. Yeah, just this guy right here. It's going overboard on me. Hold on. So copy and paste this guy right there. And then And I need to move this down a line. It line broke on me, so unfortunately. So let me move that guy down a line. I'm just showing off that I can do this, but it was pointless. So you can foil that through, and you can add, oops, I need to go and add these two middle terms, don't I? Positive 1x radical x minus 2x radical x would just be negative x radical x. And let me go ahead and just do that. Instead of creating a whole new line for that, I'll just go ahead and do it. So you can combine these two inner and outer terms, and that's a common theme in algebra. You can't always do it in every situation, but very often you can. So minus x radical x, because you can just add those two, that negative 2 would combine with that positive 1. But anyway, I mean, you can go ahead and do that. If you ever get an ABCD multiple choice format, it might give you this form right here. Now, it's not going to go further than this. I mean, by commutativity, you can put the radical in front to the left of this instead of having it to the right over here, but that's really neither here nor there. So there's this problem. It wasn't as bad as the last one. It was still a little bit demanding, but oh well. So that's all for that one. Now, finally, at long last, we get to move on to a different topic. And this is a thing you've truly not seen before. And it's getting ripe, and it's getting high time for me to introduce the second derivative, but not just yet. The time is coming fast. Some authors just go ahead and introduce you. You can do the derivative of the derivative and get what's called the second derivative, but I'm going to try to hold off just one more time. It's getting high time for me to introduce that. Let me introduce you real quick to implicit differentiation, and I'll have this whole file where you can download it and all that, to look at. But now let's say that things are mingled together, and let's say y's and x's are not so separate and nice. And let's say that y is dependent on x, and let's find dy by dx when yx plus sine y equals 2x cubed. Notice, guys, this time we can't really separate x's and y's. So you have to do a thing called implicit differentiation. Sometimes you can do algebra and separate your x's on the left side, and your y's on the right side, or vice versa. You may want to get your y's on the left and your x's on the right, but anyway, sometimes you can do algebra and separate your y's and x's. Like if you had y squared plus y plus x equals 4, you could just move your x to the other side. But here we can't do that. We have to do a thing called implicit differentiation. Well, really, to be honest with you, even if we had y squared plus y, we'd need to do this anyway, so never mind. So let's just do implicit differentiation already. So how do we find the dy? This is dy by dx. That's just the derivative, guys. How do we find dy by dx when we have when things are mingled up together? We do sort of a chain rule, product rule, sort of. Let me show you. D by dx of yx. Now, y is not a constant. In general, y depends on x. You can't just wish y away. You can't just yank out y to the side like it was a c constant. That won't work this time in general. So what we're going to do is we're going to differentiate both sides with respect to x, this side and this side. And then it's still true. Now, here's what we do. It's still true. The sum of the derivative is derivative of the sums. That's still true. All my basic rules are still true. But I got to do the chain rule on this guy. So here's what I do. And you know what? I messed this guy all up. Oops. And I made a big mistake. So this, a lot of what I've done here will be messed up. I forgot my plus y. So let's go in and do this. And now, sorry about that, guys. I wish I wouldn't have done that, but I did. And that times sign is awful messy. Let me get rid of that. So let's see. So I derivate both sides with respect to x. And then I need to proofread my stuff. It's just when I type so much, it's hard to keep track of it all. Now, by the chain rule, here's what you do. You derivate the y guy first. And that's going to be, I made another mistake. I messed this all up. big time. You leave x alone. You put multiplicatively, you put x here. You could put it here to the immediate right if you wanted to. But you derivate y with respect to x. That's just dy by dx, guys. That just, and that's not going to go away in general. And it's not going to equal any constant in general either. Not most of the time. So here we go. We derivate yx. Okay, we derivate the y part. We leave x alone. We're derivating now. The almighty question is: we are derivating. What variable are we derivating with respect to? We are taking the derivative with respect to x. This is d by dx. This is dx down here, not dy. So when I derivate y with respect to x, it's dy over dx. This is not 1. Okay? So you leave x alone, you derivate y with respect to x, because that's what we're doing, that's what we were asked for. So you got x dy by dx, and then by the product rule, plus. Now, we do y, and then we derivate x. Now, yeah, it's true, we got dx over dx. Well, excuse me. Let me do something real. So we got that, and let me get rid of that annoying time sign. So we got y dx by dx, but guys, now dx by dx, that's just the derivative of x with respect to x. That is just 1. That truly is 1, and y times 1 is just y himself. So by the product rule, I have x dy by dx plus y dx by dx, but dx by dx is just 1. That's not true for dy by dx though, okay? So I've got x dy by dx plus y. Now I've got to derivate the sign of y not with respect to y, but with respect to x. So what I do is I do the chain rule. I derivate the outside sign. I get the cosine right here, or the cosine of y, that is. But then I got to go in and derivate y. That's dy by dx. Okay? So by the chain rule, you got to stick this dy by dx here. You can't leave it off, because we're derivating with respect to a foreign variable other than y himself. We're differentiating with respect to x. So you got to have this dy by dx here. Now, guys, if that would have been the sine of x, I would just have cosine x, and that would be all, because dx by dx would just degenerate down to 1. That would be equal to 1, and that wouldn't amount to anything. But because that's sine y, not sine x, I've got to have this dy by dx here. Again, if that was sine x, I would just have cosine x. But because it's sine y, I've got to have this extra dy by dx here. You can't leave it off. All right. Now over here, we got d by dx of 2x cubed. Well, that's easy. That's just 6x squared. You know, that the variable is not foreign. Now, if that was 2y cubed, I would have 6y squared dy by dx, and because I would have a foreign variable. But anyway, now, so what have we got? So now this down here, I've got to fix this up. And again, I do apologize about that. So that now I've got this plus y I forgot about, so I need to fix that. So I subtract y over here. So I'll subtract y from both sides. That puts minus y over here. And what I do is, see this, there's an understood 1 in front of this dy by dx here. There's just a de facto 1 here. And there's the cosine y in front of this dy by dx. So I bring my dy by dx terms together on the left side, and I put my non-dy by dx terms together on the right side. So I want my dy by dx terms away from my terms that don't have it. Notice the y does not have it, and naturally the 6x squared does not have it. So I get them on this side. The 6x squared was already over here, and then I move the plus y to the other side of the equals. Remember, plus y, when he jumps across the equal sign, becomes minus y. So there's that. So I got dy by dx times that. And then the final step, guys, is just algebra. I divide both sides by entity 1 plus cosine y. And that's just going to give me, I do both sides. Excuse me, oops, I forgot to insert my minus y up there. So that's going to give me dy by dx equals 6x squared minus y over what I divided by, which is 1 plus cosine y. And that's it. You can't make this any simpler. That's as good as you can have it. And guys, I'm out of time, and I'll see you on the next video. Bye-bye.